Okay, this will be the last topic for today. So, in our last topic, we are going to discuss the exponential form or the exponential function of your complex number z. Recall that if z is raised to, if e is raised to z, that is also equivalent to e raised to x plus 1. Or, using the rule of algebra, it can become e raised to x multiplied by e raised to jy. So e raised to x is your magnitude, that is your r, and then for the angle, y is your radian angle. This topic is not that difficult. You are only required to recall the principles in algebra. So let's have an example, a quick example here. Let's evaluate e to the power of j, 4 minus j. Take note, when dealing with exponential function, you are going to use the degree, use the radian mode for your angle theta. Okay, to solve this problem, no, we can separate the into two parts. That is e to the power of 4 multiplied by e raised to minus j. So e to the power of 4 is your r, and j is your angle. Negative 1 is your angle theta. Take note, negative 1 there is in radian. So that is actually the form r of angle, r times e raised to j theta. So r times e raised to j theta can be written as r multiplied by cosine theta and j plus j sine of theta. So we are going to substitute the values. That will become cosine of negative 1, and your r is e raised to 4 plus j sine of negative 1. Now, using your calculator, you can simplify that. Take note, we are dealing with radian values. So don't forget to put your calculator in radian mode. So in my calculator, I will try the mode in degrees. Take note that is in degrees. Now we will change that to radian mode. So 4. Take note 4. Press 4. That is now in radian mode. So e to the 4 multiplied by cosine of negative 1 is 29.5. So we will round it. We will round that off to the nearest 2 decimal place. Okay, for sine function, what about sine? That is sine of negative 1. So press enter. So it becomes 45.94. I'm sorry, that is negative 45.94. Please check that in your calculator. Take note, use the radian value. So example number 2. Let's have that as example number 1. So we will evaluate. Again, for the example number 1, you are going to check if this 29.5 minus j 45.94 is correct using your calculator. So what is the real part of z equals to e raised to 1 plus j pi? So your solution is to use the rule of exponent in algebra. So write that as e, z is equals to e raised to 1 plus j pi. Now, take note, now we can use the rule of algebra. Uh, if we multiply two functions of the same basis, the exponent will be sum. So this will become your e as your magnitude, and your angle is theta. So that becomes cosine of theta plus j sine of theta, where theta is equals to pi. Take note that sine of pi is equal to 0, and cosine of pi is equal to -1. So the value of, or the real value of z is equivalent to negative multiplied by e. That's the real value. All right. So we will continue our lesson. I will try to look for problems that you will be solving. Okay, here comes your, okay, here comes another topic. So this time we will be discussing, we will be evaluating a complex number when it is raised to another complex number. That will be the last topic for today. Okay, for final topic, we are going to raise the complex number to the power of another complex number. So that is, if your complex number z is raised to the power of also a complex number that represented by w, that is the same as x plus jy in rectangular form raised to a plus jb also in rectangular form. Now, the rule is really simple. Let's have an example here to demonstrate how to solve the complex number when raised to another complex number. But first, now we are going to discuss the Argand diagram. Take note that is the real part, the imaginary part, and I will draw a unit circle. If you can still recall, the unit circle is the circle having a radius of 1. So meaning that is 1 for the real value, that is 1 times j for the imaginary value, that is -1, that is negative times j, that's negative j. Now, if we will represent this now by the angle in degrees, that will be your angle 0 degrees. This will be the angle 90 degrees. Also, this will be 180 and 270 degrees. In terms of radian, 0 degrees now can be 0 radian, or take note, this is 360 degrees, 1 revolution, that is also equivalent to your 2 pi radian. For 90 degrees, that's pi all over 2. Take note, pi is 180 divided by 2, that's 90 degrees. And of course, for 180 degrees, that is equivalent to pi radian. And for 270 degrees, that's 3 pi over 2 radian, or you can write this as negative pi over 2 radian. Okay, let's solve, or let's evaluate what is j to the power of j. Take note, j here can be changed to another form, which is equivalent to 1 That's the magnitude angle e raised to j of pi over 2. That's how you write j, that's the rectangular form, to its equivalent exponential form. Okay, let's summarize it here. J is equivalent to e raised to j pi over 2. That's that's the value of j in exponential form. Now, if I'm going to square j, that is the same as multiplying e raised to j pi over 2, multiplying the exponent by 2. So the result will be j e raised to j pi. That is equivalent to negative 1. Take note, pi, the angle pi there is equivalent to negative 1. For j cubed, that is equivalent to e raised to negative, so negative j pi over 2. That is the same as negative j, right? J cubed is the same as negative j. For j fourth, take note, j fourth can be e raised to 0, okay, or e raised to 2 pi. So it can also be e raised to 0. I'm sorry, you can't see my handwriting. That is equivalent to the value of 1. Now, if we are going to solve this problem, we are going to change j to be e raised to j pi over 2. That's your j raised to j. So when an exponent is raised to another exponent, they will be multiplied. So j and j becomes negative 1. So that means that is equivalent to e raised to negative pi over 2. That is a simple solution. Now here is an alternative solution that you will use all throughout this topic if you are dealing with a complex number raised to another complex number. Okay, assuming we are going to let z is equals to j raised to j. If we are going to take the logarithm of both sides, this will become ln of j raised to j, or it can be written as j multiplied by ln of j. And take note, j is equivalent to e for the ln, e raised to j pi over 2. Okay, take note of the exponent. The exponent will become the product. So that will become j times j pi over 2 multiplied by ln of e, which is equal to 1. So what will remain here is just j times j pi over 2. And we know that j times j is equal to negative 1. So meaning that will become e raised minus pi over 2. Now, if you are going to solve for your z, we are going to take the inverse logarithm of negative of negative pi over 2. So that's the value of z. Now let's have another example here. I think this will be the last example that I will be solving with you. So let's evaluate. Okay. Guys, are you following? Make sure you are following this calculation. Now, when I solve, I'm giving you the technique on how to solve the problem. Okay, now let's evaluate this complex number raised to another complex number. We will use the same method for the previous problem. We will let z equals to this complex number, 3 plus j4. And if you are going to take the logarithm of both sides, that will become 3 plus j4, I just write it right away, multiplied by ln of 1 minus j2. Okay. Take note, the exponent becomes the product of the ln. Now, your goal there is to convert this 1 minus j2 to its equivalent exponential form. Not polar, but exponential form. So we have 1 comma negative 1, a negative 2. So R is equivalent to 2, 2.24 e raised to j. Let's look for the angle data. Negative 1.10. Negative 1.10. E raised to minus j 1.10. 11, I mean. Let's round it out to decimal place. Multiplied by 3 plus j4. Take note, no, for the logarithmic, for the ln part, no, we can still expand that. Okay, expand ln, that will become the sum of ln, that is ln 2.24. And then the exponent will be multiplied to ln of e. Since ln of e is 1, the result will be negative j 1.1. Now, to simplify this the fastest way, you are going to use your calculator. But make sure your calculator is in complex mode. So you're going to change the mode of your calculator to complex mode. Okay, complex mode. All right, that is now in complex mode. So we will write 3 plus 4i. In your calculator, that's I instead of j. ln of 2.24 minus j, or 1.11 times I. Press equal sign, and you have now the value. So that is 6.86. Okay, 6.86, that's the real part. Okay. Minus j 0.1. Okay, 0.10. Okay, that is now the value of your ln of z. Now to solve for z, we are going to take the inverse logarithm. That becomes e raised to 6.86 minus j 0.10. So we will expand that using the rule of the algebra. E raised to 6.86 multiplied by e raised to j 0.10. So we will expand that to the trigonometric form. So this will become cosine of negative 0.10 plus j sine of negative 0.1. Okay. Using your calculator, you have to multiply that. Please use your calculator. So if you multiply that, the result will be 948.6. Multiply the other term by e raised to 6.86. That will become j 95.18. So this will be your answer. So try to check that using your calculator. Okay, now for your activity, you're going to evaluate this expression. E raised to j pi. And for number 2, 3 minus j7 is raised to j3. So you will be given 20 minutes only. Try to solve this problem. Pause the video. All right. Here are the final answers. So for problem number 1, we have 1 over e. For problem number 2, we have 32.83 minus j 6.42. All right.